Oh.
Hey, we're back.
We are back.
Just like a toothache, we're back. There we go.
Oh, I got to start talking. Yeah.
Yeah,
okay.
yeah.
Hey.
How could you ever forget that?
We do a show where we just sit here and watch, right?
Yeah, I like it. Okay. Hey, hello everyone, and welcome to our Sunday night offering of Astronomy Outreach for the November 20th. Sunday, November the 20th. The Sunday night astronomy show. Hey. Bad bunch tonight. Okay. My name is Chris Kerwin. I'm the creator and admin of the social media channels known as Astronomy by the Bay. I'm an amateur astronomer and a member of the Royal Astronomical Society of Canada, the New Brunswick chapter. And first of all, I'd like to welcome back our regular co-host, Mr. Mike Powell from the PFO Observatory here in beautiful St. John. Hey, Mike.
Oh,
Evening. And I'd like to welcome, introduce our regular co-host and fellow RAS member, Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton, New Brunswick. Paul, good evening.
hello.
Hey. Okay, we've got that
Downtown
far. Downtown Hampton.
You know, I get in downtown Hampton, for those people who've never been there, it's an interesting little place because I get in the post office and I want to get back out. We've only got one Main Street. And I don't know why, but every time I get there, there's cars coming both ways. And for the nicest little town in the east, cars don't let you out. And I'm sitting there going, man, this is just like downtown Toronto. I hate this city. And here I am in Hampton complaining about the city. So if you are a city dweller and you're thinking about a little town, we can offer a little bit of familiarity to you.
Awesome. Okay, on tonight's episode of the Sunday Night Astronomy Show, you probably heard the expression, we are made of stardust. Indeed, we are. Throughout our universe, huge clouds of dust and gas called nebula constantly form new stars and planetary systems. Now, these systems eventually give back their material to the universe to be recycled once again. Many of the beautiful nebula are within the grasp of our eyes and equipment each night of the year, but what are they and how do they appear? Now, on tonight's discussion segment, Paul is going to present a discussion on the different types of nebula and their makeup. Not that he knows anything about them, because there's a picture, one behind him all the time. So
I know
anyway,
nothing.
Also tonight, Binal Bud will return with another fine binocular target of the week, and Mike will also present his next lunar challenge. And also, Paul will be presenting another interesting Rosanna's Fun Fact segment. I'm going to provide you with a quick look at some recent space news and a look ahead. And I'll also have all of your wonderful photo submissions to share. And also tonight, we are going to be introducing our biggest contest yet. A contest really for the whole family with the generous support of one of our local sponsors. Now, this family-friendly interactive live broadcast. So for those of you joining us from my YouTube channel or Facebook page, we are happy to try and answer all of your astronomy questions here in real time as well. And of course, we'd like to welcome back all of those who have been joining us through the local Rogers TV network. Thank you for your support. So let's get started then with tonight's program and a look at Nebula. And we're going to save the bit about the contest until the very end of the program.
Yes.
So you'll have to stay on board.
Okay, so what we're going to do tonight regarding nebulosities, we're going to have a little discussion on it. I'm going to show some slides and talk about some nebulosity and show you some examples of nebula that's up in the sky. And I also have a picture that was taken by I think this one was by the James Webb, but I could be wrong. And it's going to dissect a nebula into all the different spectral views that we can take of it. And just to kind of give you an idea what nebulosity actually is. And a lot of the reason for that is if you decide that you want to look for it other than on a book or in a magazine, you're going to be somewhat disappointed if you look through a telescope, because our eye will only see a certain spectrum of light. And we don't see color very well in the dark. You know, as humans, we're just not made that way. And so the reason we want to talk about the nebulosity is to let you know that what you will see if you look through a telescope, and what you will see or what you can see if you actually take pictures of it, and the different types of nebulosity. So hopefully this will educate you a little bit on what nebulosity is, and we'll talk to a little bit. We're not scientific geniuses by any stretch, but we'll talk a little bit about the makeup of some of these different types of nebulas. So I'll jump right into it. I'm going to share my screen, and we'll get started. Let me see if I can find the one that I need. Be this one right here. And let me just know if that comes up.
Yes.
Yes, sir.
It's there? Perfect.
Velocity.
All right, so let's talk about nebulosity. So there are a variety of types of nebulas that are out there, and some of them are very, very bright, and some of them are very, very dim, and a lot of that's got to do with their physical size, as well as the color spectrum that they are. Because there are some nebulas that we can see, like if you look through even a pair of binoculars at the Orion Nebula, you can actually see it. Now, it's not going to look like that glorious blue, reds, and greens and all that, but you will see green. And then some people say, well, how come we can't see those colors when I look at, say, Jupiter or Mars, and I can see the colors from them? So, and the short answer to that is, when you're looking into deep space, you're looking into something that's very, 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 very dark. And even when you're done, if you were to take a photograph of it, you're going to have just a black image. And then you have to be able to pull that image out of that black thing. With these planets, they are so bright that, in fact, they're so bright that you don't need to take pictures 2 or 3, 4 minutes long and a whole bunch of them to get an image. You can take 1 fraction of a second and have an image of, say, the moon, Jupiter, or Mars. And with those, because they're bright enough, we can actually see the colors that are on those. But with nebulas, they are not bright enough for us to be able to discern colors. So that's just something I wanted to get through a little bit. Now we're looking at this particular nebula right here. And this one it's probably one of the more famous ones that are out there, called the Horsehead Nebula. And of course, for those who don't know what that is, we have this bit of dark nebulosity right here, this cloud of dust that's actually blocking stars behind it. But it just happens to be in the shape of a horse head. And so thus the name, the Horsehead Nebula. Also behind that, you'll see that big red patch. Well, that big red patch is what we would call hydrogen alpha. And that's typically, in our spectral ability to see it, would come off as a very narrow slice of the red spectrum, 656 nanometers to be exact. But It's just a red spectrum of light, and that's what hydrogen alpha is. What we is the color that we see it as. If you look right next to the horse head, you're going to see this very blue-like looking thing, and what that is the stars actually behind this gas, and the stars actually lighting it up in the form of a reflection, and so they call that a reflection nebula. So just in a horse head alone, just looking at these three nebulas, the three nebulas, we have a dark nebula, which is again made up of dust, and we'll get into that in a minute. We have hydrogen alpha, and we have a reflection nebula. So there are three different things going on in that particular nebulosity. So let's talk about the types of nebula that there are. So there's reflection nebula, like you see here. Everybody's seen the Pleiades or the Seven Sisters, which is the little tiny, what looks like a little tiny dipper, which rises above Taurus, which is just above Orion. So we see that in the winter time. That's a reflection nebula, and we'll get into what that is in a minute. And then there's supernova remnants. These are basically the leftovers of an exploded star. And this is the outer gas shells that were blown away, and this is what's left. So they call those remnants of a supernova. Supernova, of course, is when a star reaches the end of its life, it'll actually explode. And that's what this one does. And not all stars go supernova, by the way. There's planetary nebula, which has got nothing to do with planets. There are dark nebula, which are basically nebulas that are basically just very, very dark patches. And there are emission nebulas, which is basically what the hydrogen alpha is on this one. And this one, by the way, is actually a remnant, even though it looks like a standard hydrogen alpha type of a nebula. So, so reflection nebulas. So what are they? So reflection nebulas are clouds of dust, which are simply reflecting light. That's all they're doing of a nearby star. And when you look at the Pleiades or the Seven Sisters, which is this image we're looking at here, the reflection nebula are also usually sites of star formation. They are usually blue because the scattering is more efficient for blue light. And reflection nebula and emission nebula are often seen together and are sometimes both referred to as diffuse nebulas. So that's reflection. Now, emission nebula. This is an image of the wall in Chris's favorite constellation, Cygnus. So this emission nebula, they're clouds of high temperature gas. Now, the atoms in the cloud are energized by ultraviolet light from a nearby star, and they emit radiation as they fall back into the lower energy states. These nebulae are usually red because of the predominant emission line of hydrogen, because of the predominant emission line of Hydra happens to be red, and other colors are produced by other atoms, but hydrogen is by far the most abundant in these areas. So emission nebulas are usually the sites of recent and ongoing star formation. And I want to show you something as we get into this a little later, what's really cool about this formation portion. Now, planetary nebula, we would think, well, it must have come from a planet. It came from a planet, that name came from the early astronomers that saw these things as not stars. And they just look like blobs, like any other nebulae would have looked to them back in those days. So they just call them nebulas. And anyway, so it turns out that they are actually shells of gas from another event. So planetary nebula are shells of gas thrown out by some stars near the end of their lives. Our sun will probably produce a planetary nebula in about 5 billion years. They have nothing to do with planets. Their terminology was invented because they often look like little planets in small telescopes. And a typical planetary nebula is less than 1 light year across. So they typically are very small things in the sky. Now we have dark nebula. Dark nebula are clouds of dust, which are simply blocking the light from whatever is behind them. and they're physically very small to reflection nebula, and they look different only because of the geometry of the light source, the cloud and the Earth. Now, dark nebula are also often seen in conjunction with reflection and emission nebula, and a typical diffuse nebula is a few hundred light years across. So again, we talked about that a little earlier. That dark spot that you see right there is in fact a dark nebula, and it just happens to look like a horse. Now, we also have supernova remnants. And what a supernova remnant is, and there's a number of them, we'll look at a couple. But a supernova, when supernovae occur, when a massive star ends its life in the amazing blaze of glory. So for a few days, and I don't know if you folks out there remember, I think it was a couple of years ago now, in M81, they had a supernova and it exploded. And it was only visible just, I don't even think it was a week, and it was gone. So they don't last long. So for a few days, supernova emits as much energy as a whole galaxy. Think about that, a whole galaxy's energy, just like that. When it's all over, a large fraction of the star is blown into space as a supernova remnant. And a typical supernova remnant is at most a few light years across. So this, what you're looking at right here is a supernova remnant. This was a, what's left of a star that came to its end of its life. Now, here's another one that's supernova remnant. And this is kind of cool because this one that we're looking at is the Western Veil. And that's on one side. And then on the other side of that, there's another section of it called the Eastern Veil. And I wish I had taken a picture of all three, and there's one section in the center called the Pickering's Triangle. And if you looked at the whole thing, it looks like it's something that has a central core and the two sides that are blown out. This would be one side here. And then, of course, the other one would be way down on the other. And so these are, in fact, remnants. Now, and I'm not going to read that again because that's exactly what we just said on the other page, but I just happened to copy it. So there's the different types of supernova remnants. They can be many shapes and many sizes and whatnot. And now diffuse nebula and hydrogen alpha 2 regions. Now this is the Andromeda galaxy. And this is the one, the galaxy that's closest to our own. And someday it will collide with us. This particular nebula is a galaxy, rather, it's a spiral galaxy, but it's got lots of nebula in the galaxy. So a cloud of interstellar gas and dust which flows because of the effect on it of ultraviolet radiation from the nearby stars. The term H2 region is now preferred. The description diffuse dates from earlier times when nebula were defined according to their optical appearance. A diffuse nebula was one which retained its fuzzy appearance under magnification through a large telescope, as opposed to one which could resolve into stars. And so this one here, I don't know, I can't make it bigger, but I will show you on another image I just took. But all of those little red patches in there, those are the hydrogen alpha regions. There's a lot of reflection going on off of these young, hot stars. And of course, this galaxy has a central core. So there's lots of stuff going on here. There's a lot of gravitational activity. There's all kinds of wind going on there. This is a very, very active galaxy. And flanked on both sides, there are two other galaxies, M32 and M110. So there's a lot of stuff that's going on in this particular area of the sky. So that's the little thing on the nebulas. Now let me see if I can find, if I can show it right from here. I'd be lucky if I could, but probably not lucky enough. No, okay, I have it on another screen. So just 1 second, I'm going to stop sharing this for a minute. And I'm just going to find that other screen. So just bear with me for a second here, because I do have it. You guys can talk amongst yourselves if you like.
Overture, turn the light.
Okay, just give me a sec, I'll find it. I gotta find my bookmarks, because I bookmarked this particular page. And for some reason, it's not showing me my bookmarks. Other bookmarks. More. Oh, good golly. Isn't that always the way it goes? Because I really need to show this. Let me see if I can find it. Hang on. Bear with me again. I'm sure it's right. Oh, there it is right there. Good. Can you see that page?
Not yet,
No,
Okay.
just your pretty face.
Oh, I didn't share you back. I didn't share again. Sorry. My apologies. Share screen.
it must be the mustache.
Must
That's
be.
what it is. I can't see down. All right. So, so what you're looking at here are called the pillars of creation. And this is found in the Eagle Nebula. What is it, Mike? M17?
18, 17, 18.
16 or 17.
It's in there somewhere.
It's one of those two.
16, I think.
Anyway, so this is found in the southern portion of the sky at night. So if you're looking down towards Sagittarius, down that region, this is where you're going to find these nebulas. So this particular one is very interesting. So this is called star formation. This is called the Eagle Nebula. And down the bottom of this screen, there is what we call forming stars nestle inside dense cocoons of gas and dust, which block their visible light from reaching the telescope. So what you're looking at here are these pillars of gas. Well, there's actually all kinds of stuff going on behind them, but this is that dark nebula we talked about. So you can't actually see through it. So, but this is what part of the visible light. Let's take a look at the mid-infrared light. So this is where new star formations are. Again, some of that dense gas, but look how this looks when we're looking at it through infrared. So we're able to see a lot more interesting detail. This is all warm dust here, this really orangey red, orangey red, yellowish kind of a color dust. If we go to near infrared and right here, then we can start to see thousands of those young stars that shine through the nebula's warm, glowing, growing dust. This is where a lot of that star forming region, or star forming rather, takes place. And this is what we call nurseries, star nurseries. And what happens here, of course, is a lot of this gas will start forming. And it'll get actually quite huge, so big that it will collapse upon itself. And when it does that, it actually forms a star that way, which is really kind of cool. So this is kind of showing you a little bit of that nursery end. And again, this was the visible light that we can see with our typical telescopes. This is actually shot in narrow band. But, and if we looked at it in X-ray, then you can see most of the stars emitting high energy X-ray light, the nebula, are outside of the pillars. So it's these ones that are around the outside of the pillar. And then if we go into multi-wavelengths, then you can see high energy stars. Again, it's showing you that dark dust, emerging stars. So in this particular section right here, this is not a star yet, but it's actually forming. And what's interesting about this when I did some research is what happens is these pillars look like this now, but these pillars where a lot of this gas and dust and radiation and all of these things are going on, as they form stars, then that red blotch, if you will, the hydrogen alpha section, actually changes shape. Some of it disappears. So it's really, really interesting to be able to kind of look at it in the form of how they're actually born and where, what they do. So, and I'll just read this little thing here on the bottom. So star formation. So stars form from the remains of previous generations of stars. Stars are formed as part of an amazing recycling process in which gravity shapes new stars from the gas and dust expelled by old stars. Now, once formed, massive young stars regulate the formation of low mass stars with their powerful winds, blowing gas and dust out of the sum of the areas while compressing it in others. Now, as stars form, they are hidden inside their parent cocoons of dust that the visible light can't penetrate, but they emit infrared light that passes through the dust clouds and can be detected by infrared telescopes. The Eagle Nebula, which is the example we're using, offers views of a stellar nursery in multiple wavelengths, allowing us to see both the dense cocoons of dust and stars forming within. The nebula is home to 3 thick columns of dust and gas where the stars are forming, known as the pillars of creation. Even at 5 light years tall, the pillars have been eroded by stellar winds from young hot stars and are nearing the end of their star production phase. So most of the nebulous stars surround them, bathing them in glowing radiation that continues to chip away at their shape. So over time, they're going to change, and they are changing. And that's why there's all of these formations and variations in them. We won't see the changes because these things happen. It takes a long time, but that's kind of what the difference is in those. Let me just stop sharing that. There.
That is
Now,
so cool.
Mike and I were talking earlier about. Actually, Mike, you go ahead and ask, tell the question that Kim talked about.
Oh, like that. Before the show, my wife and I were talking, and she was saying, "What are you talking about on the show?" And it was about nebulas and the colors and stuff like that. And she said, "Well, if you took a picture of a nebula with a film camera, would you get the same colors that you get if you use a digital camera?" And I thought, that's actually a good question. I don't know, because film camera is true color, where digital camera is algorithms and stuff to make it look like true color. So it was an interesting thing. It took a quick look, and as it turns out, in the long run, yes, it does. They are interpreted the same color, or even on film, it comes out the same color. So emission nebulas, like, are red and so on because of the H alpha. But I thought that was interesting to just to look at and go, wow, it kind of makes you go, That's all.
Yeah. Well, Mike also showed showed us an image, Chris and I, an image of North American Nebula that was taken with film, and it was as red as you please. And then we're thinking, hold it now. Did they have hydrogen alpha filters back then? I don't think so.
No.
But when you think about it, if you're in imaging at all, what's the one modification you make to a DSLR when you first buy it? If you want to use it for astro imaging, is you pull out the infrared filter, because that infrared filter is actually what's blocking and stopping you from seeing that red light, and it's helping correct us to see the pictures that we take in the daytime in the colors that we're used to seeing them. But if you pull that out, you're going to get a very red cast. But in film, they didn't have infrared filters, right? So
straight through,
yeah. So we were thinking, how the heck did they end up with an absolutely gorgeous color red, full, glorious color, without filters? Anyway, because it was without filters.
Yeah, amazing.
Yeah, it was really interesting.
The other neat one was that whole thing about what is the primary colors?
Right.
Yeah.
Oh, well, there. Question. Don't anybody look on their phones, and don't anybody look on their computers.
Right.
What are the 3 primary colors? And go.
Right.
Let's see.
Paul and I got a little bet going on what the answers will be. Which way they lean.
Don't look at your computer. Just answer.
Right. Don't Google it.
What are the 3 primary colors?
What are the 3 primaries?
Who's come up with the answer first?
I'm waiting to see.
We're waiting to see.
I guess we're all
Interesting question, though.
red, blue, and yellow.
Stefan? Yeah.
That's one.
That's one.
Else? Red,
Yellow,
red, yeah.
blue, red. Meg. Hey,
blue, and
Meg.
yellow.
RGB. There you go.
Red, blue, and green. Okay. Anybody else? Cyan, magenta. Okay. What Stefan said. Red, blue, and yellow. Red, blue, green.
Red, blue,
Okay.
green.
So just based on that information we've seen right there, it's the answer is red, blue, and yellow.
Yellow.
But
Blue and yellow make green.
Yeah, we are so in step with thinking that the primaries are red, blue, green, because we have red, blue, green cameras, RGB, and in the astronomy world, that's what we're taught. RGB gives us our broadbanded colors.
And monitors, RGB monitors, and so on.
Now, you guys are probably too young to remember CHSJ.
Well, you have to be from St. John first.
Right. And
TV or radio.
remember they had the 3 circles?
Oh, yes, that's right.
Yes. Yeah.
4, 7, and 6 were the 3 channels, I think, and they had red, yellow, and blue.
Yeah.
Like the peacock.
Yeah.
Yeah. Well, the peacock.
Yeah. But anyway, so that's interesting just to see that. But in any event, because of that, the color spectrum, we talked a little bit about what theorized, how could they, with digital cameras, could they make it better than what we could see with film? But not really, because it doesn't matter. Our human eyes are able to see a certain spectrum of light. And so whatever it is that we're filming or using digital cameras to capture, we have to satisfy the light that we see. So when they're shooting in infrared, which we can't see, they have to fill that in with some kind of color so you can see what it is that the infrared catches. So we are limited by what we see, but there are light bands that are far beyond our capability. So
Right.
Anyway, so in this whole emission and nebula talk that we put up there, we just wanted to kind of bring that to the forefront as to what is a nebula, the different types. If you ever decide you want to view or observe deep sky objects, then there are certain filters that you're going to need to work with these different color spectrums of light. And the same as when you're trying to image anything. If you want to image, natural star colors, you're not going to use narrow band filters because you won't get those natural colors. They're designed in different chunks of light. So anyway, that's kind of where it goes at the end of it. But it's just interesting how these stars form, what the nebulas are, and because we probably don't talk about that a whole lot.
Not a whole lot, no.
Not at all. That site that you were showing, Paul, what was the name of that? Where you're showing the different pictures of light.
That is called View Space.
View Space, yeah.
Yeah.
I like that.
And,
That's pretty cool.
Yeah, it's just called Star Formation, and it was the Eagle Nebula. It's something really neat to look at.
Mm.
I was gonna, I guess we'll know, and for the sake of time, I'll stop it there. But there are some other things that really make it really interesting when you're imaging this stuff, because when you do it in really high resolution, and you can actually study this, you can actually take your own pictures of these nebulas and all the stuff that are here. If you record them in a high enough resolution, you can blow them up way beyond what you're seeing me here, and then you can actually go right into these individual spaces on your images and start looking at these different sections. And you can see this in star nurseries and the hot star sections, and where things are all gathered and compressed together. It's super interesting once you understand a little bit of it.
I see we get a part 2 coming down the road.
That's neat stuff.
Yep.
I saw at the bottom of that page too, there was a comment that what we're seeing for the Eagle Nebula is not what it looks like in real life today, because it takes 1,600 years for the light to get to us.
Exactly.
So it's probably gone, or mostly gone.
That's right.
So,
Yeah. Or changed
or changed at least at minimum. Yeah.
That's right.
I see a comment here. It must have been about CHSJ, because I see Meg Burley says nope.
Oh yeah,
She
I
don't
saw that,
remember.
yeah.
Nope.
No, Meg wouldn't. She wouldn't have been around for that.
Nah.
I don't remember having 3 channels.
I remember having one channel. I remember getting up from the floor and turning the channel from channel 4 to channel 9. It's like, whoa, look at this.
The tin foil on the.
Oh yeah.
Ears.
We're standing there like this.
Yeah.
Try to hold them for a 1 hour show.
Yeah.
I went through the Rhoda's flea market this weekend, and I saw one of those old RCA antennas he used to buy, and it had the 2 controls on it, and you could spin the antenna and all that stuff.
Yeah.
We used to use coat hangers in
we did.
our days, right?
Yeah.
Oh yeah.
Yeah.
Just
Can't use them today. They're all plastic today.
Yeah, but by the
That's
way,
right.
we're talking about how we're able to pick up our television signal to put it on our TVs.
Yeah.
We're
Probably
telling
should
the-
educate people on that. I was my dad's first remote control. Lisa says.
Yeah, we all were, I think.
We all were there.
Yeah,
Yeah.
that's right. Yeah. Turn that channel.
Thanks, Paul.
Somehow
That was
I had
great
to
talk.
open the fridge for the beer all the time. I don't know.
Thanks so much, Paul. That's great. Great,
Yeah,
great
absolutely.
information. Nice to
Yeah.
look at that side of it for sure.
That's cool.
Even though it was Cygnus, I didn't mind too much.
Well, there you
Um,
go.
There you go. Mr. Mike, could we do a Bino Bud talk maybe?
I know, Bud Talk. See if this comes up.
There we are.
We got it?
Yes, sir.
Alrighty, binocular target of the week this week by Bono Bud is, and I was going to do this last week, but unfortunately we ran out of time. Davy's dog. Ta-da. All right. Between Hyades and Pleiades lies a star group just visible with the unaided eye. You because Davy's dog is pretty large, you can observe this asterism best with binoculars, just like the Pleiades. Look for Canis Major constellation shape. Davy's dog lies just north of the northern constellation Taurus, the bull. John Davies, for whom the asterism is named, he saw a beagle when he looked up. I didn't see a beagle, but okay. So there's Pleiades. Oh, and go outside at 2300 or 11 o'clock tonight. Orient yourself if there's no clouds. East-southeast at 110 degrees. Look up, you will see the Pleiades or Pleiades. Come down, you will see the front end of Taurus with Aldebaran, the eye of the bull. And it's right in between the two and just up a little bit. Look, he's right here. Davy's dog.
Oh, look at that.
Doesn't that look like a doggy?
He looks like one of those balloon dogs.
Yeah,
Yeah.
not a beagle. Alrighty. Well, this is what it looks like if you took a photograph, because there's Hyades and Aldebaran, and there's Pleiades, and he's right in here. Look, there's the nose, the ears, the legs come down, out the tail, up in the back legs.
Oh, yeah.
Or in 10 by 50 binoculars, look at the size of this thing. There's the nose, comes up to the ears, down. There's one leg, another leg, and the tail goes up here. So there it is, Davy's dog in binoculars. It's huge. Compared to the full moon, I wouldn't even have 7 full moons in size. Like, he's big. He's pretty big. You can definitely spot it when you look for it anyway. So that's binocular target of the week was Davy's dog, and that's astronomy in the Maritimes. Binocular target of the week by Bono.
Thanks, Mike. Another great target. Yeah, and that's a primary target right now too, right in Taurus, right? Yeah,
right up there.
Easy to find with Mars are right close by too. So awesome. Thank you. Okay, how about we do a quick what's up, Doc? What's up, Doc?
What's up, Doc? Talk. Yeah, SOS pads used to hang from the antennas as well.
Oh, yes, yes.
Right, yes.
Anything that had metal, right?
Oh, yeah.
That's right. Yep. Okay, I'm going to try this out. Get the right screen up.
What up this week?
Okay, that's it. Hang on. So from beginning. Okay, what is up this week? Just got a few things to talk about. Only 9 slides here because there wasn't a whole lot that I could see that was actually happening in the night sky this week. But you've got lots to look at anyway. Taurus is up really nice. Orion, all those normal things.
And Davy's dog.
Yeah, and Davy's dog. Mars is getting close to opposition as well. So, but for this week, I just wanted to mention first of all the Artemis mission, of course, our Artemis mission, get off the ground. Nice to see that go finally. But on Monday, tomorrow, Orion, the part of the spacecraft that is on its way to the moon right now, will fly by the moon on Monday morning. NASA's Artemis 1 mission will arrive at the moon's neighborhood on Monday morning on November 21st, and you can follow the action live. Now, Artemis's 1 uncrewed Orion capsule has been cruising towards the moon since Wednesday morning on November the 16th, when it launched atop NASA's gigantic Space Launch System, or SLS rocket. Orion will finally reach the moon Monday morning, skimming just 80 miles or 130 kilometers above the lunar surface at 7:44 a.m. Atlantic time. If all goes according to plan, during that close approach, the capsule will fire its main engine in a powered flyby burn, which will set it on course to enter the lunar orbit 4 days later. Now, Artemis 1 team members will be explaining, I'm sorry, that's supposed to be 7:15. Explaining and discussing the crucial maneuvers during the webcast that starts Monday at 8:15 AST on NASA's YouTube channel. I think it's 7:15. Anyway, there'll be a live broadcast. Now, it's not going to be video, I don't believe. It's just going to be a couple of snapshots, but they'll be talking about it anyway. Actually, I think it's going to be behind the moon when it's at its closest approach, so we're not going to get to see it actually at its closest approach. But nice to see that we're going back to the moon. We're getting close. Here we are with mission number 1. Number 2 is next with some live crew members on it, not just Snoopy and a few other fake animals. And then number 3, of course, we're back landing on the moon. This is a little chart for this week coming up with the ISS passes over our area for the next week. Tonight there was a really nice pass at minus 3.8 at 6:18 tonight. Now, there was some discussion too about something that flew over St. John this evening. I've got I think probably 15 different emails to respond to of people that sent me in links. Some of them are actually videos of this horizontal projectile that went over the top of the city this evening, about 5:50, I guess, this evening Atlantic time. And they were asking if it was a meteor, but it looked like it was going much too slow for a meteor, and it was breaking up into pieces. So I expect it was probably a defunct satellite or maybe a spent rocket, something like that, that actually entered our Earth's atmosphere tonight.
I think it was Santa Claus being a little early.
It might have been that too. Might have been. He's really early. Okay. So we do have a number of passes coming up tomorrow night. Minus 3.1. That's a really nice pass. 43 degrees altitudes at 5:30 and ending at 5:36. And look again on Tuesday night. There's another nice one, minus 3.3. And Wednesday night, minus 3.7. That's another really bright one. And so all this week, some fairly bright passes, some nice times as well. They're all the evening passes, so that's good to go back out and take a look. So you can find this at courtesy heavens-above.com. Just visit that site, and on the top right-hand corner of the site, it'll ask for your location, punch in your location, then update your page, and then go back and click on ISS, and that'll give you all of these dates if they're passing over your area. Next up from there, I'm going to go to Thursday's main event, which is the Io and its shadow transiting Jupiter. Now, this has happened a number of times. Jupiter continues to dominate the evening sky. It's a really bright object out in the evening sky now. And its moon continues their transit across the faces throughout the week. On Thursday evening, now telescope users can track another transit of Io and its shadow across the face of Jupiter. Now, the transit of Io begins at 1933 and ends at 21:46 Atlantic time. So that's a couple of good hours anyway. And the shadow begins its transit at 20:26 and ends at 22:59. So another couple of good hours to keep an eye on it. So you get lots of time if you're out there with the telescope and you want to take a look at Jupiter, see if you can capture that shadow like that. Wednesday is our new moon. Our moon begins a new cycle on Wednesday evening at 6:57 Atlantic time. Now, these few days before and after the new moon are also wonderful times to enjoy all of those deep sky treasures that are really otherwise washed out by the bright light of the moon. So all those nebula that Paul talked about are great for viewing at this time of the season, or this time of the month. Thursday, November 24th to Thursday, December 15th. Here we go. This is a very special Shoot the Moon contest coming up, Christmas contest sponsored by our friends at Cliff Valley Astronomy. Now, the new Shoot the Moon and the Planets 2 contest will begin on Thursday evening, the first day after the new moon. The contest is going to close at midnight on Thursday, December the 15th. All prizes will be awarded on the Sunday Night Astronomy Show on December the 17th. What are the prizes? That's coming up a little bit later, and what the contest rules are. And it's actually broken into two parts. There's one part of the contest for adults and one part of the contest for kids. So looking forward to bringing that to you. Also, don't forget, you can always go to Lisa's Lookup, Astronomy and More. Lisa Fanning supplies us this chart every month. This is our one for November. I expect our one for December coming out soon, Lisa. You can find Lisa at Ruby Moonbeams on Instagram, Facebook, and Twitter. And what she does is she lists the events here, the dates of the events, the peak times when it's best to view those events, and what you need to view them with, either naked eye, binoculars, or a telescope. So you can find Lisa at Ruby Moonbeams on Instagram, Facebook, and Twitter. And if you're in the area and you want to take a look at our calendar, you can go to sjastronomy.ca, download our November, December calendar here. This lists all of the special events, I'll say, for the month of November and December. We're going to come up to December the 8th. I want to pay attention to this one right here on December the 8th, because on that date, not only is Mars going to be at opposition, but Mars is also going to be occulted by the moon. The moon's going to pass in front of Mars. And it's not as rare to have a moon pass in front of a star. It becomes a little bit more rare when you see the moon pass in front of a planet. But to have the moon pass in front of a planet when that particular planet is actually at opposition at the same time, I think that's very rare, probably extremely rare. So we're going to bring that to you live here on YouTube and probably Facebook as well on that evening. And I'll have more details on that a little bit later. It's actually posted up on Facebook right now, but I'll be putting a post up on YouTube as well. So that's what we got to say about this week. We got a couple of comments here. Any links to a video upload of that event over St. John? Piplo, if you want to go back to my Facebook page later on, I can certainly put the link up there if you're on Facebook. I can try to find the link here for you as well once I sign off this part. Anyway, that's what to look for this week. How's that?
Cool.
Yeah,
That's cool.
Yeah.
yeah. It'd be interesting to find out. I haven't looked yet. I'm sure some have already planned for it, but to see the brightness level of Mars versus the moon, because the moon will be full. And will you be able to get detail when they're both that close together? If you can, that will make an awesome occultation.
Oh yeah, absolutely. So we should talk, guys, about maybe offering it ourselves.
Yeah.
But we'd like to get a nice, great big moon and a little tiny Mars in the corner, because
Oh,
it's just
yeah.
going to catch it passing in behind. So it's only going to be a half an hour show, but it'll still be quite nice. Right after midnight, I believe.
Yep.
Brad says someone sent me a video of that projectile too. I thought it was flares from Gagetown, but there's actually made no sense. Yeah, I think it is probably a spent rocket booster or something like that that's gone up.
Artemis.
There's a lot of yeah.
Coming down.
There's a lot of them up there, a lot of space debris. But
Yeah.
pretty neat that so many people saw it. That's great that many people were looking up.
Yeah.
That's what we're all about here. Okay, how about Rosanna's fun facts maybe next?
All right, let's see if I can share my screen here. And I'm going to do this week's.
Rosanna's Fun Fact.
Yay! Welcome back, Rosanna, for another amazing fun fact. And this one is, well, I keep saying that every time because I find them all so interesting. But this one I really, really think is so cool. And excuse me with my pronunciation for some of these names, but I will try my best. Okay, so Rosanna says, hi, Paul. Throughout the ages, there have been explosive words of catchphrases that stick with generation after generation, all the while evolving. Things like Geronimo, Cowabunga, Zowers, Groovy, Bazinga, Ay caramba, yada, 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 and holy blank, Batman, and so on. I'd like to add a new one, Super Kaimo Candy. Kaimo Candy. That's, and I'm going to say it like that. It makes me think that perhaps Super Mario Kart went through the microwave and morphed into a radioactive AI gamer on YouTube. There's a sentence I never thought I would type. Okay, so I'd like to add, what is the Super Camo Candy? It is one badass, amazing creation, that has progressed through time on Earth, actually deep inside Earth, with fascinating scientific results. Let me see if I can get my mouse working here so I can get these photographs up. There we go. So, Super Kayokandi is a neutrino observatory located under Mount Aikino in Japan. It's located 1,000 meters or 3,300 feet underground in the Mozumi mine. The observatory was designed to detect high-energy neutrinos, to search for proton decay, study solar and atmospheric neutrinos, and keep watch for supernovae in the Milky Way galaxy. Whew, that's a lot. It's a big list. Find the tiny people in the photo. Can you see the little people in the photo?
Yeah.
Way over here.
Up to the side.
It consists of a cylindrical stainless steel tank about 40 meters or 131 feet in height and diameter, holding 50,000 metric tons of ultra pure water. Mounted on an inside superstructure are about 13,000 photomultiplier tubes that detect light from the Cherenkov radiation. Okay, so what's Cherenkov radiation? So here we go. That is so cool. So this is a classic example of the Cherenkov radiation. Is the characteristic blue glow of an underwater nuclear reactor. It causes this, its cause is similar to the cause of a sonic boom, the sharp sound heard when faster than sound movement occurs. More specifically, a neutrino interaction with the electrons of nuclei of the water can produce a charged particle that moves faster than the speed of light in water, which is slower than the speed of light in a vacuum. This creates a cone of light known as the Cherenkov radiation, which is the optical equivalent to a sonic boom. The Cherenkov light is projected as a ring on the wall of a detector. I think there's another image for that. There we go. Of a detector and recorded by the PMTs. Using the timing and charge information recorded by each PMT, the interaction vertex, the ring direction, and the flavor of the incoming neutrino is then determined. From the sharpness of the edge of the ring, the type of particular can be, or type of particle rather, can be inferred. The multiple scattering of electrons is large, so electromagnetic showers produce fuzzy rings. Relativistic muons, there, yes, try to say that again, create sharp rings. So as will this. So there's another image of, let me just shrink that one down, sorry. There's another image of it, another way to look at it. In 1998, the Super Kamiokande announced the first evidence of neutrino oscillations. Unfortunately, on November the 12th, 2001, about 6,600 of the photomultiplier tubes, each costing $3,000, imploded in a chain reaction, also termed as a cascading failure, which sounds prettier. The shock wave from each tube cracked its neighbor, a domino effect. I could not find out how it started or how it stopped, but each tube now has a protective acrylic shell that is hoped will prevent another chain reaction from reoccurring, and Super Kamiokande 2 was created. Now, gadolinium, there we go. Gadolinium was introduced in the tank in late 2019. Gadolinium, let me just show you that. That's not them, but has an affinity for neutrons and produces a bright flash of gamma rays when it absorbs one. Adding gadolinium to the Super Kamiokande allows it to distinguish between neutrinos and antineutrinos. Antineutrinos produce a double flash of light about 30 microseconds apart. First, when the neutrino hits a proton. Second, when the gadolinium absorbs a neutron. The brightness of the first flash allows physicists to distinguish between low energy antineutrinos from the Earth and high energy antineutrinos from supernovas. In addition to observing neutrinos from distant supernovas, the Super Kamiokande is able to set off an alarm to inform astronomers around the world of the presence of a supernova in the Milky Way within 1 second of it occurring. Now, that's pretty impressive. The Super Kamiokande has now become the Hyper Kamiokande with new tunneling and other improvements. And that's what you're seeing here, is that image. I could not find out how many supernova moments either the Super or the Hyper Kamiokande have registered, but it is probably a fair amount considering this statement. Every 2 to 3 seconds, a supernova goes off somewhere in the universe, and it produces 10 to the 58th neutrinos, says Mazia Nakata, who leads the Super K and international cooperation led by Japan and the United States. So fantastic investigation into some of the tiniest particles in outer space and is registering and being recorded daily deep within Earth. And a new catchphrase, although mostly only known in the scientific circles, has been born. Let's gadiate. As a result, we're not busy scooping large quantities of gadolinium salts into big vats of water. I've been industrially traveling the globe, spreading my message. Let's gadiate all the detectors. And that is this week's
Rosanna's Fun Fact.
Hey!
Well, that was a mouthful of stuff, I got to tell you.
Wow, I'll say, yeah. You think
But,
neutrinos was hard to say? Boy,
It's unbelievable what I get from all of that is how they can make those measurements of something so small, so accurate in such a short period of time. That's just unbelievable. Within a second.
yeah.
I read an article where those are full of water and divers go inside have to wear rebreathers because they can't allow bubbles. And they actually get vertigo because they don't know what direction. It's so clean and so clear, they actually don't know what direction they're facing.
Oh,
Oh,
wow.
wow, really? Yeah.
And no bubbles coming out, right?
Yeah.
Because
Yeah,
that
so
would
they don't know what,
contaminate it.
yeah.
But it was kind of cool to see that.
Yeah.
It was like, wow.
Wow. Amazing stuff.
Anyway, that's amazing. So another great fun fact from Rosanna.
Oh,
And,
yeah.
thank
Yeah.
you so much for that.
That's awesome.
Every week I'm learning more.
She does a lot of research for sure.
So I'm
Thank you,
telling
Rosanna.
She's educating
Absolutely.
us. I'll tell you that.
Absolutely. Yeah, 100%. Okay, let's go from there to a lunar challenge.
All
What do you
right.
got, Mike? What do you got from a lunar challenge, Mike?
Well, the lunar challenge is shifted by a little bit because we missed it last week, and boy, the moon moves a lot in 7 days. So anyway, binocular moon crater challenge for the next opportunity. We already looked and saw Clavius right down here.
Yep.
And it has the little craters inside in that semicircle. That's actually a test of your scope's view. And tonight we have, Alphonsus. I think I got it right this time. Alphonsus has a diameter of 119 kilometers and a depth of 2.7 kilometers. The floor is fractured by an elaborate system of rills and contains 4 or 5 smaller craters surrounded by symmetric darker halo. These darker halo craters are cinder cone-shaped and believed by some to be volcanic in origin. Alphonsus is named after King Alfonso X of Castile, known as Alfonso the Wise. And Alphonsus is one of the most primary alternative landing sites considered for both Apollo 16 and Apollo 17. So if you know your history, there's a hint as to where it's at.
Mhm.
So that's our binocular target of our moon crater challenge. And here's a picture of it, Alphonsus.
Wow,
And you can see all the rills going through it.
Mm.
I really
You can see
can.
what's that?
I really can.
Oh,
Yeah.
jeepers, come on.
You got beat up. And anyway,
Oh,
I'm sorry.
so when the moon comes around next time, because we're coming up to a new moon next, and it's kind of hard to see this stuff during a new moon, then take a look and see if you can find out where and see Alphonsus. That's
Awesome.
binocular target.
that's
The
lunar
moon.
challenge.
Lunar
Yeah.
challenge.
Yeah.
That could be a
Binocular moon.
binocular target or a
It could be.
telescope target. You pick one.
Absolutely.
All
We
right.
don't care. As long as people look up, doesn't matter.
That's right. Well, Mike, that was really fascinating.
Uh, can anybody ship in Paul a few jokes or one-liners,
I'm
please?
sorry.
Please.
They asked me one time, I did a test. They asked me to do a sentence with the word fascinate in it. So I thought for a second and said, I have a leather coat. It is great. It has 11 buttons. I only fascinate.
Okay,
Hmm.
we're going off track here.
No, we just entertain ourselves. That's
Yeah, that's okay.
We're allowed.
Okay, let's go with some photos, and then we're going to get into the contest because I want you to hold on for that. Yay! Okay, let me get my photos opened up here first of all. Try this one.
We need photo music.
We do need
Yeah,
photo
we
music.
do,
Yeah,
don't
we
we?
do.
Yeah.
Can't sing though. We're not allowed to sing because
No, no.
they'll pick us up and shut us down. You know, remember.
Do like
Okay.
the bees and hum. Don't know the words.
Okay, let me see if I can share my screen. I'll share these guys and let's try to bring them up over here.
Well, there's a photo challenge, right?
Okay, there's a photo challenge for you. Yeah.
There
Let me get this up here. Here we go. How's this one? There. How's that?
There we go.
we go.
Oh, I can't do it that way because you guys are in my way. Bring it
Oh,
down.
no, Mr.
Yeah,
Bill.
darn it. Well, see, the three of us are on the right-hand side and I can't minimize this, I don't think. No, I think I saw me able to do, maybe. Yeah, there you go. Hey there, you're out of here. Woo. Okay. You still there?
Yeah, yeah.
Oh.
I was just looking at that
Okay.
giant picture.
Yeah, it's a giant picture, isn't it?
It is a giant picture.
Oh, why is it a giant picture? Oh, there we go. Let's do it this way. Here we go.
There
There we
we
go.
go.
Hey,
There
that's better.
Hey!
Mr. Matthew Dupre sent these in. I recently reprocessed my data of the Wizard Nebula. The data was taken last year. I took it with my Celestron 9 1/4 Hyperstar and Canon T3. After I reprocessed it, it ended up getting some of the blue color to come out, kind of like the way this one looks.
Yeah,
Look at the right picture.
Awesome.
Yeah,
yeah,
Nicely done.
nicely done.
very nice.
And look, they're all getting large. Oh, boy.
That's
Here's
a nice
another
shot.
capture. This one is also from Matthew. He said, managed to get this shot of Orion just as the clouds started to roll in.
That's
Look at how
it.
big it looks at the horizon, eh? So
Oh, it's monstrous.
Oh, man.
it's just like that's like the moon illusion, how we see, look at it, it's reflecting in the water too.
Yeah.
There's the belt. Cool. So this is why they appear big. It's just like that, a moon illusion. When the moon appears large at the horizon, the constellations also look large at the horizon.
Yeah.
Um,
Especially if you're looking at something that's a long ways away.
right. That's a long ways away, that one.
Yeah. No, but I mean the shoreline.
Oh, the shoreline. Sorry. Yeah, you're right.
Yeah.
Sure.
Sure.
Shoreline. Thanks,
Okay,
Matthew, for those.
Nice
Great
shot.
stuff.
Very nice.
Got this one from Carol Bean. Carol said, I made an attempt, she said, to capture the Pleiades this evening. This is one of my photos. This is one of the photos, 3.2 inch at f6, sorry, ISO 5000, a Canon 60D with 200 millimeter lens. So she got it right in there.
Yes,
Oh,
sir.
yeah, absolutely.
Nicely done.
See some of the clouds?
Yep.
Isn't that
Nicely
nice?
done, Carol.
Very nice.
Okay, thank you for that. Let's go on to Mr. David Hoskin next. I think this is him. Yes, this is him.
Jupiter.
Yeah, go.
Jupiter, maybe just last night, he said, with my Celestron C8 SCT and ASI 224 MC, seeing was poor with thin cloud. So not much detail is visible among or beyond the major cloud bands. But I say he did pretty well.
Oh,
I
yeah.
think you did well too. You can see some
Yeah.
festoons and stuff
The
there.
bands,
No,
Sure you can, yeah.
yeah.
Curling right back there. Good
Yeah.
stuff.
Some festoons and the bands, all kinds of cool stuff.
Nice stuff, David.
Yep.
Let's move on to his couple of shots of his moon. These are incredible.
There
I
you
love
go.
these.
Yeah,
They're-
there's some nice detail there.
Yeah. So I
Wow.
captured these lunar images, he said, this morning just before dawn with my 8-inch SCT and an ASI 290 mm.
Very nice.
Sure. Nice shot.
Yeah,
Beautiful detail.
those will be right there. Look at that.
Yes, sir. Fantastic.
Oh, nice.
Look, some more rills.
Yeah.
Really, right there.
Really?
Well done. Thanks, David.
Very
Love
nice.
looking at the moon shots.
Never gets old.
I'm going to be looking at a lot of them here soon, I think. Hopefully. Okay. This one is from Robert Cadet, Starfield just off CAPH, CAPH in Cassiopeia, a single 3-minute exposure.
Yeah, so there's the heart, soul, and the double cluster.
Double cluster. Yep.
Double cluster here.
Yep, right above it, just to the left, a little higher.
Here.
There you go. That's the heart nebula, and the one
Okay.
beside it is the soul.
Cool.
Very nice. A lot of stars in there.
Nice. A lot of, yeah,
Oh,
crazy,
wow.
crazy amount of stars.
Yeah.
Unbelievable.
Right in the heart of the Milky Way, really.
Hmm. In the heart. Uh-huh. Okay. And this one, you got a quick shot of the Pleiades. He said that my battery died, but
Ah,
Well, look,
Nice
now
shot,
look at the
though.
see the reflection nebula there?
yeah,
Yeah.
right there. Look. Yeah. That's
Yep.
just what we were talking about, Paul. Yeah.
Very
That could
nice.
be that must be the leftover dust and gas though from what would have formed these stars, I guess, eh?
Well, those are brand, like those are new, fresh, young stars.
Right.
Yeah.
Yeah, so there's lots of gas and stuff that was there when they were forming. and-
Right.
And now they're just reflecting and lighting it up.
Very nicely done.
Yep.
And this one, he said, first crack of the double cluster in the Heart and Soul Nebula. Not a very good picture, he said, but it's a Star Adventure Pro Canon T7i ISO 800 f2.8 single 3-minute exposure.
wow, there's so much in there.
Oh, there's incredible amount of stuff in there.
Wow.
A lot of stars. My gosh.
Unbelievable.
Yeah, until you can get those objects to pop right out, There's so many stars, you gotta really know where to
Yeah.
look.
Yeah.
Crazy.
Well done, Robert. Thank you.
Very nice.
Yeah.
We're going to move from there to, no, this is this final one here of, sorry, we're looking at Heidi's cluster in Taurus
Yeah, there's Aldebaran right down there in the corner.
and Aldebaran right down here in the corner. Yeah.
Yes,
Nicely
sir.
done, Robert. Good
Well
stuff.
done.
Thank you for those.
Very nice.
Okay, going to move on to Kathy Adams now. Kathy's coloring the moon.
Yes,
Scroll out.
it's
Let's see
it's
here.
hard
May I
to
just
get
get over
those
the
colors right. I
shot
think
there?
Matthew Dupre did that a while ago,
Yeah.
and
Yeah.
there's lots of color up because there's lots of different minerals.
Oh, there's so much color there.
Yeah, we look at the moon as just being, whitish gray, but we never really realize that there's that much color in the moon.
Yeah, there's all
Yeah.
kinds. She captured it well.
Very well done. And we're going to go to this shot of the moon.
Hey, moon.
She
We're not
says,
getting it all.
she says, took the dogs out, saw the moon this
There
morning.
it is.
Yeah, there is, and beat the clouds. She said single shot C5 Celestron and a Sony A6000
Wow, eh? Nice detail.
for single shot.
Very nice.
Awesome. And look at the Apennines, just cracked right
yeah.
out it.
Oh, right there, yeah.
I love them, eh?
And Eratosthenes, and there's Copernicus. Boom, boom, right off the bat. Eratosthenes, he was the guy who calculated the circumference of the Earth back 4,000 years ago. Kathy got this one as well. Nice Io moon,
Transit?
or the transit of Io and the moon actually, or a shadow passing across. Yeah.
Oh, yeah.
So well
Nice.
done, Kathy.
Yep, nice.
The 17th, and their Mars shot. Look at Mars
sir.
now.
Yes, sir.
Made you,
Mars.
you wonder why they thought there was a civilization there when you see it like that, right? Back in the old days.
Yeah, yeah. Well, you look
Yeah.
at what looks to be continents,
Yeah.
and then
Yeah.
of course the ice cap.
Yeah.
Yeah. Polar caps.
Yeah,
Nicely done.
very nice.
Gonna move up into this one from Jamie. Jamie, why not? Says, hi, Chris. I'm a week late sharing these, but this is my total lunar eclipse photos from November the 8th. I missed the start of it due to clouds, but it cleared enough for me to get some shots. I lost the moon into the trees not too long after totality and taken with my iPhone 8 through my 8-inch Dob. Nice, huh?
Wow. And better late than never.
Oh, she got it.
You got it all, yeah.
Yeah. Very
It's funny
nice.
when it got really, really full, or when it got total rather. I
Mm.
was watching it, and it was actually becoming daylight, and
Yeah.
it was interesting to see how the sky started to light up, just that little bit of almost like that blue hour that we get,
Yep.
and the stars were popping. It was something to look at. It really was.
I really liked it when we were watching it being eclipsed and the sky darkening right down.
Yeah.
Like, you're used to big bright full moon, and then all of a sudden the stars were starting to
Well,
pop out.
and that's what I found interesting, is that you could actually see stars all around the moon.
Yeah.
Right. Yes,
Before, because they're so bright, right?
that's right. Yes. Well done. Thanks, Jamie.
Yeah, good job.
I'm going to move on to this one. I don't know why they're doing all this. Get back to right size here. This one came from Trudy
There you go.
Yeoman.
That's split rock.
Yeah, and zodiacal, that is too, right there. And the zodiacal light. That's
Yep.
what she's trying to capture here. It's like a meteor shoot through here.
Meteor or satellite?
It's Beach, that guy's name Beach, just before Split Rock.
No, he means, I think he's talking about the
The line. The line's
what's
a
shooting through
satellite,
there.
I
Yeah,
think.
might be satellite. Yeah.
Mr. Musk.
Anyway.
Yeah. Anyway,
Blame them all on him.
the zodiacal light on October 31st at 6:26 a.m. Visible naked eye, but I've seen brighter. She said my single image never shows it as well as the thumbnails do. So she got some thumbnails here for us too.
Yeah, I really
There you go.
popped
Oh,
there.
yeah.
Yeah.
And the thumbnails do show it up really nice. Yeah.
Absolutely.
Well done.
That's a hard one. It's a faint. It's very
It
faint.
is.
So it's tough to get.
Well, the last time she got it, I think she got it with, there was cloud because I was with her.
Right.
And, but this time there was no cloud, so it looks pretty good.
Oh,
Yeah.
right on.
Oh, very well done. Thanks, Trudy. I'm going to move from there. Hang on a second. Get my notes going here. Oh, this one here from Mr. Powell.
Oh, it was this morning.
Yeah, this morning.
I got up at 5 o'clock this morning for that.
There you go.
I love
A
that.
bit of
Earthshine,
waning
eh?
moon with Earthshine. Yeah.
Yeah.
Getting very slim now. Nice shot, Mike.
Not a whole lot left of it.
No.
It's close to the sun, boy. It broke real fast.
There's something magical about that Earthshine, isn't there?
It is,
Yeah.
yeah.
That is without Earthshine. She started lighting up pretty quick.
Yeah.
What time of day
George.
was that, Mike?
It started at, well, I got up at 5, so I was out there by 5:30 sipping my coffee. So between 5:30 and 6:30.
Yeah.
Nicely done.
Yeah.
And this one,
Oh,
wonder who that one's from. Let me see.
Yeah,
Who would that be?
that guy.
Mr. Paul Owen with the Triangulum Galaxy. The Triangulum Galaxy is a spiral galaxy 2.7 million light years from Earth in the constellation of Triangulum. It's cataloged as M33 or NGC 598, captured from my backyard in Hampton. Sure
Yeah.
was.
You got nice guys in your backyard.
If you just
Wow.
leave it there just for a second, and we'll talk just briefly about the nebulosity that we talked about.
Yeah.
And star forming regions. So if you look at all of those red areas right there, if you were able to zoom in any closer than I can on mine, I don't know if you can on yours before it deteriorates, but you'll see that in the center of those big heavy red patches, they're full of stars. And on both sides. It was unbelievable. And I was looking at that. And they're starting to resolve a little bit there now. You can start to see that there's actually all these pinpoints of stars right within that nebulosity. And so those stars are actually formed. But there's other ones, if you look just below it, that one right there. That one's, it's not formed yet. So it's not a pinpoint sharp pop of light just yet. And it's interesting. I started looking at all those different areas, and you can actually start to see a variety of stages that they're in. It's really quite interesting to look at all that stuff. But
so these are clouds of dust and gas that are building around these stars, and these stars are colliding into each other. I think that's part of it. Like the clouds are colliding into each other, causing these larger clouds. Are they not?
And what's happening is the clouds are getting more and more dense. And the more dense they get, eventually they will just collapse within themselves. And then it creates another star. And then when that happens, of course, the gases that you're looking at now are going to be totally different shape or even disappear.
Right.
Fair enough.
A lot of it too is these stars that are coming around the outside here.
Yeah.
They're at different speeds as they're moving around, right? So the faster ones cram into the ones that are going slower, and that's what causes these starburst areas as well, right? Areas where stars are collecting in the large clouds, just like you'd be going around at different speeds if you're on any part of that galaxy, I guess. They bunch up in spots where you're coming onto a freeway basically, and you're on one of the on ramps, and everything gets slowed down, and everything gets bunched up together, and that's why you get these big clusters of stars with the star birth happening inside them.
Yeah.
Amazing photo, Paul. Very nice.
Yeah, thanks. But it's just if you just go down right to that, see that bright star, and don't you go to your right just a bit,
With
right there, now just below that, right, you can see a combination of
blue and red.
Yeah. So again, it's just when you sit there and look at this stuff for a little while and start to kind of look at what we talked about earlier, you can sort of start to put all this stuff together. So taking images just doesn't become pretty pictures anymore. You can really study astronomy.
Right.
Taking the photographs, right? I find that so intriguing.
I remember you saying back a while when we talked about looking at like taking photos of the night sky or taking photos of the moon, and you want to learn something about the moon, the best thing is to go out and snap some photos of it and sit down and look at it, right? Like you said.
Yeah, just start
Learn
to
a lot.
study.
You know what would be interesting would be to see a supernova remnant in another galaxy.
Yeah.
Right?
Yeah.
That would be so cool if you could get it.
Yeah.
Probably James Webb will get it eventually.
Yeah, exactly. Yeah, you watch and see.
Yeah.
And for anybody who'd like to send in photos, again, we love to get them. Here they are. Here are our addresses: Sunday Night Astronomy Show at gmail.com or snaz at astronomybythebay.ca. Snaz for a Sunday Night Astronomy Show. And I watch for these two addresses constantly to see what's coming in on them. So please send them into those, and we'd love to get them.
Yes, indeed.
Okay.
Yay!
Yay!
So you were going to mention some kind of award or something?
Oh, was I?
A what?
The astronomy thing that the three of us got this week.
Oh, well, do you have a picture of it? Because I don't have that up.
You had it up.
No, I had just a image of us without it.
Yeah. Oh, I thought you had it up
No,
there.
no. Can you share it?
Just a sec, I'll see if I can find it.
Okay, I'm going to try to get the other part ready to go.
The only reason I even want to bring this up is because somebody was left off of it, as far as I'm
Oh,
concerned.
that's true.
And I wanted
Yeah.
to make mention of it. You just give me a second.
Absolutely.
See if I can find it here.
This picture here, I got it.
Yeah, but Mike, can you bring it up?
Yeah, one sec here. I think it's this one. That's the one we're looking for.
That's
Yes,
it.
that's it.
So, so this weekend, Mike and Chris and I were presented with the President's Recognition Award from Rask, New Brunswick, for, you know, the work that's been done with basically since the pandemic, really, and whatnot. And we appreciated it and we were humbled by it, but there's somebody that's not on there that I think should be included with that, because she's been with us from day one.
Absolutely.
Been with us physically, but she sends us her amazing fun facts every week. So I would like to think that Rosanna is part of this as well. So I just wanted to say, if I had my druthers, Rosanna would be here too.
Yep, we'd love to get her on the show.
Yeah, she's as far as I'm concerned, she's just she's part of us too.
Oh, yeah.
Yep, 100%.
Yeah.
Yep, I agree. Thanks, Paul, for bringing that up. That is very true.
Yeah.
It would be a different show without Rosanna's fun facts for sure.
Absolutely.
We appreciate every topic that she gives us for sure. Okay, let's go from there to talk a little bit about the contest. We're actually past our time a little bit, but I'm going to spend a little bit of time talking about this because I think people might want to know. It shouldn't be very long, so let me share my screen here, and I'll bring up what's going on. I'll go with this one, I guess. No, yeah, it was this one, yeah. Okay. You guys can see that okay?
Yep.
Yeah.
Okay, so let's go to our slideshow from beginning. And we'll talk a little bit about it. Here we are. So we're going to offer a very special Astronomy by the Bay SNAS Sunday Night Astronomy Show Shoot the Moon Christmas Contest. And it's being sponsored by our friends at Cliff Valley Astronomy, Stefan Picard. As him and I have been talking for a little bit, he's asked if he could offer a contest on our page. I said, of course you can. He'd like to give away some nice prizes for Christmas, and I said, of course you can as well. So we're going to be the medium here to allow him to play Santa this year. So let's get a look at what's going on. Okay, so first of all, the contest rules. We're going to have another Shoot the Moon contest. Partly that. Now the contest rules are going to be broken up into two parts. The first part is going to be this kind of a neat one. Contest rules for age 12 and under. So there's one part of prizes that are going to be awarded for them. Now, if you had a Cliff Valley Astronomy Star Party, draw what you think you might see in the telescope. So what we're looking for is drawing, hand drawn, of what you might see if you were looking through a telescope. Is it going to be the moon, Mars, aliens, space, UFOs? Doesn't matter to me. Spaceships, whatever it is. Have a parent snap a photo of that drawing and then send it in to this address, snaz@astronomybythebay.ca. So very simple little project. You want to have some fun with this. So really like to know what your ideas are on what you can come up with for what you would see through a telescope if you were looking through a telescope. And there's a reason for this, and I'll tell you in a second. So that's part one. For those that are 12 years old and over, I'm going to go back to this. We're going to capture a new, quote, new image of the moon with any device, not something that has been sent before. You can send your entries to snaz@astronomybythebay.ca, the same address. There is no judging. There is never any judging on any photos. I don't judge photos. I just want participation. All images are going to be treated equally. Now you can share your post, share the post of my Facebook page when I put it up on Facebook for your second entry, and capture one of the planets for a third entry. Okay. Now the deadline for the entries is going to be midnight on Thursday, December the 15th. Now, where are the planets right now? Well, look at our sky. We've got Mars over here in Taurus, really bright red object right there. We get really bright Jupiter in our southeastern part of our sky, right in Pisces. And then we have Saturn over here in Capricornus. That's still here for a few more weeks. So you've got an option of any one of these 3 planets that you can capture, and that'll give you another entry into the contest. Okay, so what are the prizes for those aged 12 and under? Stefan has offered a couple of mint condition telescopes. These are used, but he has reconditioned them, and they are back to new, spanking new condition. So the prizes for those 12 years of age and under, one prize will be a mint condition 50 millimeter Celestron travel scope. So the telescope packs up into this backpack. You get a couple of eyepieces with it, a diagonal, and you can get a nice view of the moon, the Pleiades star cluster, Milky Way, that type of thing with it. So this is for those 12 years of age and under. That's one prize. Our next prize is going to be a mint condition 60 millimeter Celestron telescope. Approximate retail value of those prizes are each about $100. So that's a second prize for those 12 and under. The grand prize for those 12 and under is going to be a 2-hour private star party for up to 12 people with a value of $300. Now, Stefan is going to set up a private star party. He brings his equipment to the location that you both decide on and the date that you decide on as well. Maybe it's a child's star party, Christmas party, whatever. But it's a 2-hour private star party for up to 12 people with a value of $300, along with a mint condition Celestron 50 millimeter travel scope. So you get both travel scope and the star party together. A total prize package of about $400.
Wow.
And we're going to keep going here. Now for the prizes for those aged 12 and over. I'm saying 12, but I'm saying, you know, we'll look at it. First of all, we're going to come up with a copy of the Royal Astronomical Society of Canada's Observer's Handbook. This book is filled with facts about the night sky for the upcoming year, when to see the next year's best celestial events, and much more. Approximate retail value of that is $35. Stefan is also offering 2 copies of the 2023 RASC Observer's Calendar, 2 of the Royal Astronomical Society of Canada's 2023 RASC calendars with beautiful night sky images in them, approximate retail value of $50. Third prize is this one, the Monopoly Spaceboard game. Have fun with family, enjoying all about space Monopoly game. One of these games is available to be won, approximate value of $30. These are all making nice Christmas gifts. And finally, the grand prize for those aged 12 and over is a brand new Celestron Explorer LT 114 AZ Newtonian reflector telescope with star sense technology. Now this is presented by Cliff Valley Astronomy and Astronomy Plus, a great telescope dealer out of Montreal. And the approximate retail value of this scope is $300. And what happens with this is that you set up the telescope, you put your smartphone on the telescope, you align the telescope, and you actually turn the telescope right or left, and the app on the iPhone or the phone will tell you which direction you should be turning, and it lights up the area where you are. So you can find objects much easier with this type of telescope, with this type of star sense technology. It's all the new rave right now anyway. So that's going to be the grand prize.
Nice.
So some nice prizes. Total value prize package about $1,000. Contest starts now, remember, on Thursday, November 14th, and it's going to end on midnight on Thursday, December the 15th. Everybody on Instagram, Facebook, and whatever social media channel I'm on are eligible to enter. All entries, though, must be received by December the 15th at Thursday night, and they all must be sent to snaz@astronomybythebay.ca. I'm not going to collect them off my Facebook page. Please send them to that address, because there's going to be so many entries that I have to keep track of. So I want to bring them all together as one, and I don't want to miss anybody along the way. So special thanks again, of course, to Stefan Picard of Cliff Valley Astronomy and the folks at Astronomy Plus. These are wonderful prizes. Thanks for the donations. I'm more than happy to be able to pass these out. And Stefan is going to join us on the night of the draw to make the draws for everybody. So Merry Christmas, and there's our happy Santa able to offer away some prizes. So good luck, everyone.
Wow.
That's our contest. I'll be posting all that information up on my page a little bit later too. So
That's awesome stuff.
yeah. Okay, so we're going to keep you posted on that. That post will be up on my Facebook page and Instagram shortly. And as we get closer to the midweek And the first day of the contest again is on Thursday. So I'll remind everybody about it then. Okay, so then on next week's show, poor little Pluto, the planet that was, or is still depending on, depending on who you ask. Now, since the IAU decided on what makes a planet, there has been a lot of talk of whether or not they were right. Next week, we're going to talk about what constitutes a planet, big or small. Also, remember that our newest contest starts on Wednesday. Remember, get your entries into snaz@astronomybythebay.ca. So in closing then tonight, we'd like to thank you once again for your continued support of our efforts, here. Our special thanks once again to Rosanna for continued contribution to our program. Absolutely. Rosanna, thank you very much. We really do appreciate it.
Yeah.
We also know that those of you who have joined us from Rogers, hope you enjoyed the program as well. If you would like more information about the wonders of the night sky, you can contact me at astronomybythebay.ca. Also, a special thanks to all of you who share our program out there. We really appreciate it. And remember, we do love getting your photos, so send them into snaz@astronomybythebay.ca or sundaynightastronomyshow@gmail.com, and we'll be happy to include them on our next broadcast. If you have suggestions for a topic for a future show, please let us know at the same address. And please let your friends and family know that we will be back here next Sunday night at 8 p.m. on YouTube and Facebook to edutain you on astronomy and the wonders of the night sky. So for now then, from Mike and Paul and myself, we wish you a safe week, lots of clear skies. And as we like to say, guys, open your eyes to view the skies and keep your scopes pointed up. Good night, everyone. Cue the music.